a derivative of architecture.
I'm not gonna lie, like I walked by there and these kids just like doing nothing in there. And I was like, the ELC is literally like nice.
Study hall without kids on the corner. Could you like take a nap in there? Yeah.
Okay, here's the plan. Question.
If you get sent to the ALC, does that like have any effect on anything? Like, does
In
that
what
go?
way?
Let's try it.
Like, I mean, does it go on transcripts or anything? Like, sweet. Because I walk by there and there's these kids like doing nothing, and I'm like, some days it just looks so enjoyable. They're just sitting on their
Jamie, I've had enough.
Like all 4 years, I've only had one person get sent to the ALC in my class.
Yeah.
And it was in careers because that's not.
I've sent people there.
Have you really, Mr. Johnson? What?
Watch yourself.
I like how you said you had a move and that got captured on. Why have you had like, you act like you're the teacher that's like, oh, it's like calm and cool, like.
You haven't seen me with freshmen.
Oh, with freshmen? Yes. That's awesome.
No, I get really annoyed by people who are not partaking in the experience of this education. And there are some that are out there like that.
Libby wants to lay on the couch, therefore ALC.
There's no couch in the LC.
Yeah, the kids in ALC like should be forced to do homework or something, but they just sit on their phones.
Like a blanket.
Mrs. Brennan.
All right, I guess it's time. You guys are in the mood for a motivational speech? Okay, so what is life? Okay. Yeah. So, you know, it's funny. You're asked since you're a little kid, what are you going to be when you grow up, right? And you always pick something, one thing or another, and all that. But none of us has any idea what's going to really happen. And life comes and goes, and it does these weird things, and you can take these twists and turns and all that. And so I've looked at it this way. Used to think of life as just, you are always striving for success, right? Success. And so what is success? Okay, that's the question. Being happy, okay, that's a good one. Okay, sometimes it's determined by wealth or status or all of these different things. And then you think, well, the reality is if you can, in your lifetime, have moments, hopefully long moments, where you are doing something that you love to do, you are good at it, and you can make enough money to support yourself, okay, and others if that's needed, then I would say that would be success. Okay? And it doesn't matter what you do. Okay? People can have lots of different kinds of jobs and still satisfy those things. Okay? So, another way to look at life is to say that, you know, no one ever really arrives. Ever. Okay? You may reach a point where you feel pretty good about what you're doing and all that, and that's good, and sometimes that can be referred to as arriving. But you know, the reality is as you go through life, it's more about collecting experiences that you can learn from that make you better in whatever that you are planning on doing. Just think about it. In most cases, either good things that happen to you or bad things that happen to you. You know, it's either good or bad at the time. But if you really stop and think about it, after time goes on, if you reflect and you learn from those things, nearly almost all experiences, good or bad, can turn out to be good. It just changed perhaps the course of your trajectory, but it's still, in the end, as long as you learn from mistakes, that's what it is. So think about that in terms of life. You know, people are always obsessed with, I got to do this at the right time. Got to be college here, and I have to get this, and everything has to be in its place. Well, the reality is it doesn't. My belief is that I hear life is short so many times. Life is short. You know, it's carpe diem. We got to do it now, all that. And that's not bad. But I've learned that life is actually pretty long. It goes by quickly, but it's actually pretty long, which means you have the opportunities to make mistakes or do some stuff completely wrong or not know what you're going to do, and there's still time. One of the biggest things is people pick a career path, and all of a sudden they decide, oh man, this sucks. I hate doing this. Okay, guess what? Life is long. Change it. You've got time. It's not that sense as life is short that you got to just stick with it and do it, blah, blah, blah. No, you have this opportunity to continue to do something completely different if what's currently you're doing is not working. So think about that. So now, what about the tool chest? Okay? So in the minds of collecting experiences, there's all sorts of things in here. I got this here. Okay, we got calipers. We got all sorts of stuff. Big long tape measure. Oh, this is loaded with stuff. How about a cheese slicer? That's what everybody needs, a good cheese slicer. But let's see what you guys have been doing. This is the math tool chest. So let's see what your experiences have brought you so far. So we know a little bit about this. We know a little bit about that, right? If you don't have these things, it's pretty hard to do harder things, right? So, uh-oh.
No, just skip that.
Computer science people know what this is.
Yeah, it's death. Skip it. No.
It's the remainder when doing integer division. Ooh, okay. Then we should know about these if we're going to do math and be able to be good at it, the big picture. We have to be able to do this. We have to be able to do those, right? This kind of comes in handy, knowing what those are and what we can and cannot use. These come in really handy to do lots of our work. These come in handy at times. Okay? Should do a whole class on fractal geometry. That'd be fun. And that correlates with these. And then other math things. Okay? These are all tools that you have used. Right? Big category. Lots of stuff there. Even these things. If you think of it as an experience, as you go through your math courses, you've picked up all of these experiences. And they are what allow you to do harder and harder things. Okay? All of these things are things that we have to know about. This one we haven't done much yet. Okay, this is a big one in calculus, right? It's the slope, but it's when the units are different. Uh-oh. Then we have this. Okay, so these are some things that we've added this year, right? And it's important that we know each one of these to be able to do the things that we need to do in calculus. Right? Now what's that? That's in the future. We haven't gone here yet, okay? This is down the path that we haven't gotten there yet. It correlates to this. And you have to know everything prior to that in order to be able to do this. Okay? This one. This one. Ooh, look at this one. This one kind of seems important. Okay, so look at that weird notation. Okay, and we're back to where we started. So life is about picking up experiences and using those experiences to do a better job at whatever you're going to do. In calculus and in mathematics, it's the same thing. You have to take you have to just pick up these things, play with them, and that helps you to be better at the next level. Okay? Or in general, it helps you to problem solve. All right, so here's the plan. You picked up two things. I want you to be able to do both of those by Monday so that you can compare answers. Okay? And then you're going to get a new one on Monday. You're going to get a new one on Tuesday. Okay? And then the test is on Thursday. Okay? With chapter summaries, do that. So I thought we would just do one extra one for starters today. So pull out your notebook. Let's just jot this one down. How the heck do we find the arctangent, the derivative of the arctangent, and then evaluate it at f prime at x equals 1/4? So, does anybody have that copied down? What is the derivative of the arctangent? The derivative of the arctangent of u, okay, where u is some function of x, is equal to 1 over 1 plus u squared times the derivative of u. Okay. So it's 1 over 1 plus u squared times the derivative of u. So, for this problem, 4x is our u. So the derivative of the arctangent of 4x is 1 over 1 plus 4x squared multiplied by 4. So, what is f prime of 1/4? That's the slope of the line tangent to the arctangent of 4x when x equals 1/4. Let's see here. I got 4 over 1 plus 4 times 1/4 squared 1 plus 1 squared. Final answer is 2. Go to the ALC. Who? No, she's on her way to Madison. Okay. Okay, any questions on there? Those are all on page 374. There's a big table there. And that's all. I'm not going to say anything more about those. All right, so I'm going to take the rest of, well, whatever it takes to do these 4 problems. These are the ones that are the top ones that you selected for from the e to the x section, which was page 357. So I'm going to go over those right now. And then you have work time. If you're all good with all of these, you don't need to listen to me. You can work on those other things if you want to. So, okay, let's go with number 52. Find the equation of the tangent line. Here's the function. There's the point. So, the directions still stay the same, or the steps to solve it stay the same. Find the derivative, then find the slope, and then use the point and the slope to write the equation. So here we go. Y prime equals. So the natural log of that blob is 1 over that blob multiplied by the derivative of the blob. Now I'm going to show you what I'm going to do with this. This thing right here, I'm going to write this as 1/2 times e to the x plus e to the negative x. See, it's over 2? But I'm going to write it like this because then this is written as a constant times a function. So then I can just take the 1/2 and then multiply it by the derivative of what's in the parentheses. It's the constant multiple rule. So the derivative of this, which is the derivative of this, is the same as 1/2 times the derivative of e to the x is e to the x. The derivative of e to the negative x is e to the negative x times -1. So this is the derivative of that function. Well, let's clean it up though. Now, a little bit about fractions. So I have 1 over this, okay, which means that I can take the reciprocal. It's 1 divided by this. So it means it's the same as 2 over e to the x plus e to the negative x, which is then still times 1/2, still times e to the x minus e to the negative x. So this thing turns into that thing. Well, then the 2's cancel. Okay, it's 2 times 1/2. And just for clarity, this becomes e to the x minus e to the x, negative x that is, over e to the x plus e to the negative x. And this is what my derivative is. No. So let's evaluate it at 0, at x equals 0. So this is going to give you y prime of 0, because I only have x here. So I have e to the 0 minus e to the 0 over e to the 0 plus e to the 0, which is 0. You get 0 over 2, which is 0. So that just tells you that your slope is 0. So this is not very climactic here. 1 minus 0 equals 0 times x minus 0. That's using the point and the slope. Which means that the tangent line to this crazy equation is a horizontal line at y equals 0. And we could prove it by graphing it and then drawing the equation and see how it touches only at one time. Okay? But for me, doing this, it's more about the process because it's impossible for me to do all possible examples. It's more important to me that I teach you how to go about a problem. That way. All right, this one says find the second derivative of that function. So let's do it. So the first derivative, and you should be getting good at this, the square root of x, that's x to the 1/2. So its derivative is actually 1/2 times x to the negative 1/2, which is 1 over 2 square roots of x. If you do the math, it's 1/2 times x to the negative 1/2, which is 1 over 2 square roots of x. Okay, plus the derivative of e to the x times natural log of x, well, I spy product rule. So the derivative of e to the x is e to the x times natural log of x plus e to the x times the derivative of the natural log of x is 1 over x. And that's your first derivative. So the second derivative, here we go. So let's see, this is 1/2 out in front, but then that's really x to the negative 1/2. So this is going to be negative 1/2 times x to the negative 3/2, because I took negative 1/2 minus 1, which is negative 3/2. Okay, then we take the derivative of this and we take the derivative of that. Well, look at this. The derivative of this was all of this. And so I'm finding the derivative of this, so it's going to be this one plus this one is what I'm going to put down here for the derivative of this one. In other words, this is e to the x times natural log of x plus e to the x times 1 over x. And that's what this one is. It's this whole thing here. Then we got to do the derivative of e to the x times 1 over x. And, you know, I probably would do this one as, I would think of this as a quotient, e to the x over x. Because then I'm just going to do quotient rule on that. So quotient rule, bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. And this is the second derivative of the original equation. Okay? And cleaned up if we need to. All right, number 61. Find the second derivative of this thing. So, let's treat it as a product that it is. So derivative of the first one is 2 times e to the negative 3x plus 3 plus 2x times the derivative of e to the negative 3x, which is e to the negative 3x multiplied by negative 3. So that's your first derivative. It's just product rule. within the product rule, it's derivative of e to the u. I think I'm going to just clean this up before I do the next one. 2e to the negative 3x plus, I think I'm going to multiply this thing inside here. I'm going to multiply the negative 3 times each of these. So it's going to be negative 9 minus 6x times e to the negative 3x. And then we do round 2. Round 2, the derivative. So 2e to the negative 3x, the derivative is 2 times e to the negative 3x times negative 3. Basic rule on e to the u. Then we have to do product rule here. So the derivative of the first is negative 6x times e to the negative 3x plus, the first one sits out, negative 9 minus 6x, multiplied by the derivative of the second, which is e to the negative 3x times negative 3. Then cleaned up, whatever way. Now I know I can go through these faster than I did the first time when I was originally teaching it, because you guys have all done this multiple times. I know that you tried the problem, and then you didn't get it right, then you tried it again, and then you tried it again, and then you looked it up on Slater, and it didn't work out. So then you talked to a couple of friends, you posted it on the Facebook page. You know, you went through all of that, so that allows me to just go through this kind of quickly, because it's just about filling in the blanks. So I get that. I'm sorry if I'm going too slow. All right, next one, the derivative of this thing. This is going to require implicit differentiation because of the y's embedded inside. So the derivative of e to the xy is e to the xy multiplied by the derivative of xy, which is 1 times y plus x times dy dx. That's your standard product rule. Then the rest, derivative of x squared is 2x, derivative of y squared is 2y dy dx is equal to 0. Now we're supposed to find dy dx, so that means we have to solve for dy dx. So we have to distribute here. So we have all the different terms that have dy dx's in them. So I'm going to distribute this. This is going to give me y times e to the xy plus x times e to the xy times dy dx. And then just these tag along. Then I'm going to leave the terms that have dy dx's on this side. I'm going to put the other ones on the other side. So I got x times e to the xy dy dx. That's this one. Minus 2y dy dx equals, I got that one. And then we'll put those other ones over there. So it's negative 2x minus y e to the xy. Then I can factor out the dy dx and then divide. We've done that a dozen times now. So negative 2x minus y e to the xy over x e to the xy minus 2y. Piece of cake. Approach every problem just step by step by step. Don't look at the problem and get freaked out. Just do it one at a time. You look at a problem like this, you might want to just run down the hall screaming. That phrase has special meaning to me. No, my mom did. When I was a kid, I was kind of accident prone. I'd be like breaking bones and getting scars and all that stuff. Well, anyway, I was in the garage one time. I was like 7 years old, and I slipped on a pencil, like rolled on it, and my dad had this big pile of bricks there. And me being me, I slipped and my face slammed on the bricks. And so I've got a scar right here on my eye. It got cut. And I like get up and I feel my thing, and then there's just blood everywhere. So I go in to the kitchen and my mom sees me and I'm like full of blood. And she turns around and runs down the hall screaming. Not very good with the blood thing. So then my sister came out and then she cleaned me up and all that. So I got a couple of stitches. So don't do this. She's 4 years older than me, so she would have been 11 when I was 4. She was a very responsible 11-year-old. Apparently, yeah. Okay, by the way, it's possible that on the AP exam you do a multiple choice question like this, and you get this, but this answer is not there. But the answer that is there looks like this. Remember this? See that? If you switch every term to the opposite sign, it's exactly the same thing. The only difference is that we had our dy dx on the left side, but if you switched it around the other way, put the dy dx on the right side, then you get this answer. They're both correct. But if it's multiple choice, you got to pick the one that matches. Okay, that does it for today for me. So your job is to work on either one of those two sheets that you got in front of you. And then we'll look over all of them. The next 3 days will be spent collaborating and defining everything that we know.